differentiation with a chain rule. This is a little bit more difficult than, for example, the differentiation with sums, for example, or with the factor rule. And I can show you how it works. Basically, you just need to keep in mind the rule, which is take the outer derivation times the inner derivation. So outer derivation times inner derivation. This is how it works. This sentence you should keep in mind when you want to apply the chain rule. And I also have it on paper for you. So chain rule is you have a function which is like, this is called a chain. You have a function within a function which depends on x here. And when you want to do when you want to differentiate, you just take the outer differentiation, the outer derivative times the inner derivative. Outer times inner, and that's how it works. But I know this is when you apply it. I mean, this may look quite easy, but usually when you apply it in exams or at university or at high school, then it may be more difficult, since usually there are several tricks or difficulties. And so what I can recommend is a lot of practice with the chain rule, so that this is not a problem. In principle, I would say it's not difficult, but of course the functions, the type of functions which are in the exercise can make it a little bit difficult, and that's why I would suggest practice. But I will show an example in the following clip. How about differentiation with the chain rule? It works the following. We have a function which is a little bit more complicated, and since it's sort of two combined functions, and they look the following. We have one function which we call u, and we have an inner function which is called v, and we want to differentiate now. And the chain rule says take the outer derivation times the inner derivation. So outer derivation would be we differentiate u, inner derivation would be we differentiate v. And that's what we are going to do with this function. Looks very general in this case, so we differentiate the outer function, so u differentiated. And note that the inner part stays the same because we differentiate just the outer part, not the inner part. And now times the inner derivation. Looks actually quite easy, but I know especially at university it gets quite complicated. But in principle it's very easy, and if you apply it just like this, then it should work. But the thing is always the rule comes combined with another rule, which is the product rule, which I will introduce later, and of course the terms will get quite complicated. But the rule itself, I would say it's not too complicated, but of course you need to practice it so that you don't make mistakes with this calculation. So let's just have an example, which is the following. We have a function f, and the function is 3 plus 2 times x to the power of 2 minus 1 to the power of 3. And we already see, okay, there's some outer part, there's some inner part. This is the inner part, so it would be v of x, and the outer part is the u of x, right? So that we can compare it to the rule that I just introduced. We don't have to care about the 3. If we would integrate, then the 3 would matter, but when we differentiate, of course, there's no x, so the 3 just disappears. Why is that? Maybe I can just explain it. We have a function which is, I mean, it doesn't really matter, right? But this is, if this were f, then this would be 3. And when we differentiate, the derivation tells us about the slope, and the slope is always the same, right? And a function that tells us just about the slope doesn't tell us about the y-axis intersection. So the outcome will be just the slope and not this y-axis intersection. So we lose always this information when we differentiate. But when we integrate, then we have to think about this just as additional information. So we just differentiate and then we see what happens. So the 3 disappears, and now just as we said, the outer derivation, which is in this case, we use the power rule, which says 2 times 3, or we can just write write differently, 2 times 3, as I just said. Then we keep the inner part, minus 1 to the power of 2, that's the outer derivation, that's u differentiated, times the inner derivation. And the inner derivation is, this also disappears, and we have 2x then. Right? And now what can we do? We can use bracket rules, we can exclude 2 times 3 is 6, times 2 is 12, so we have 12 times the inner part, x to the power of 2 minus 1, and this to the power of 2 times x. And what we're going to do now is we differentiate again, and in this exercise we see, okay, when we differentiate here again, then we not only have to use the chain rule, but we also have to use the product rule, since we have another x here. But how does the product rule work? Okay, let's assume we have some f function, we have u, and some v. The way it works now is, it's going to be a little bit narrow. So the way it works, we have u differentiated times v plus u stays the same now times v differentiated. So we have sum, and in the first part the one function gets differentiated, and the second part the second function gets differentiated. Right? I think it's also not too difficult, but now we see in combination with the chain rule it gets a little bit complicated. But this exercise is still very easy, I would say. So we differentiate again. 12 we don't really have to care about it, since it is just a factor. So we just write it again. 12 stays the same, and that's also why I excluded those factors, so that it looks a little bit easier at least. So now we differentiate the first part. Within the first part we use the chain rule, and when we use the chain rule we start with the outer derivation. Outer derivation is 2 times x to the power of 2 minus 1. Outer derivation. And so product rule, we keep the v, nothing changes. Now plus we keep the u, which is this strange term here, and we have x to the power of 2 minus 1 to the power of 2, and we differentiate now v in this case is x differentiated is 1 times 1, so we don't see it actually. So looks wait, I think, did I forget something? We have x to the power of 2 when we differentiate is 2x, so I forgot an x, right? So it should be, we just add to the power of 2, and then it should be fine again. Since this, the outer derivation of this is 2 times the inner part times the inner derivation. The inner derivation is 2 times x. I wrote the 2, but I forgot the x, 2x. We should take care of. So this is it, and now what can we do? We can start to try to include the 12 again. We can calculate a lot. It depends on the taste, on what you think. Maybe it will look nicer, but in this case I would say it doesn't really look nicer at the end. So this is how it works, basically chain rule. Always remember, when you have chain rule, you take the outer derivation times the inner derivation. So you should be able to write down the general form as I did with u and v. And then also in this exercise I had to use the product rule, which is you end up with a sum where the first element, the first function is differentiated, and in the second element, the second function, which is v, is differentiated. So each function gets differentiated once and appears in one element of the sum. This is how it works. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheets.com.